So before we go to the graph questions, I want to quickly show you in Desmos how different things affect the graph. So for example, this is the graph 2 to the value of x. Again, I don't so much care what b is when I'm doing my transformations, because all b talks about is really whether it's growth and decay and the steepness. And I'll give an example. This is 2. This is going to be 3. It's going to be the same y-intercept because nothing else has changed. It's just going to be steeper closer to the y because it's the number 3. So if I click that, you're going to see that that's happened. This will also be steeper than both of these. But again, it's still going to go through the same y-intercept because nothing else has changed except b. So what I want to show you is that b doesn't really matter in terms of if you're not talking about growth, decay, or steepness. If you're talking about transformations, b does not matter at all. So I'll do the same thing with the fractions so you can see. So I have 3/4. So there it is. This one is going to go through the same y-intercept. It's just going to be, let's see, it's a smaller fraction, so it's going to be steeper. So boom. All right, then 1/8 is also a smaller fraction than all of them, so it's going to be the steepest. Boom. And you're seeing that it goes through the y-intercept. Now, while I'm here, okay, I want to show you a couple of things. Let's say I take a decay problem. So it's just important. B is only there to tell me if it's growth or decay and the steepness. So I'm going to take a decay problem. If I want to reflect this over the x-axis, I need to add a negative outside. And again, if you don't know that, please watch a previous video so that you're not lost time. And now if I flip it, it's flipped over the x-axis. If I want to move it up or down, right, I go outside, not inside with the x, and I move it up or down. So I can do +2, it's going to go up. So you can notice you can do one of two things on this one, by the way. You can use the y-intercept. So the y-intercept is going to go up to 1, 2, or you can use the isotope. So this is the isotope, this line, it's going to go up 1, 2. So 1, 2, and this is the new isotope. So kind of pick one and you can go with that. If I wanted it to move it down 5, I'll just say -5 because exactly what I think, and look at the y-intercept. It's moved 1, 2, 3, 4, 5. Or you can look at this isotope right here, which has moved 1, 2, 3, 4, 5. Okay, so again, pick one and don't get confused. So whichever one you prefer, please go with. All right, now we're going to look at the x. So again, if I want this to stay up here, I need to put it in parentheses. If I'm moving left and right, now what you have to consider is this. You're finding this y-intercept, and then you're kind of looking at where this line is. So for example, if I do, let's do -3. Okay, so you see the y-intercept is no longer 1 because it's moved, okay? And really, I'm just going to zoom out so that you can see it. This is where the graph was initially, and it's moved to the right. And that would make sense because this would be opposite because it's -3. So that was moved to the right. If I want to move it to the left, I can say +5, for example. And you can see that this line has now moved to this line. So I kind of zoomed out so you can see. The key thing for you to know is this. If it's moved to the left, it's like further away, like that one. Let's go in a little bit more. This one is further away to the left. If it's moving to the right, you can see it's like a lot steeper, so to speak, but it's moved to the right. And that's something that's going to be a little bit difficult for you to see, but I'm hoping that as we go through this video, you'll understand. So now that you know that, we're going to come here with no calculator. All right, so we're given a graph. It's a solid red. Oh, well, it's not red. Mine is purple. I think yours is red. All right, complete the function for the dotted graph. So this dotted graph has had some movement happen to it. So if I'm looking at this, in order to become the dotted, for one, I can see that it's flipped, right? So I flipped it. If I flip this back over, and again, you're not drawing this right now, just listen for a second. If I flip it back over, it looks like that, right? So if I flip the red line, it's going to become the green line. So in addition to it being flipped, so a flip is over the x-axis, a negative on the left. In addition to it being flipped, it's also been moved because this is what it was originally. So it was originally this, right? And now it's been flipped. And actually mine was not this because I can already tell mine is supposed to be a decay problem, and all of a sudden it's growth. I think that one is your function. But whatever mine is, has been flipped, and then it's also been moved. So it started here, and then somehow it's over here. So it looks like it's been moved really up and also to the right. So let's talk about up first. So I'm going to do it with my isotope because I cannot see my y-intercept. So here's my isotope right here. This new isotope is right over here. So it's been shifted up how many units? 1, 2. So up means that I need +2 on the outside. Now, this is where it gets tricky, the left and right. And so I don't think they'll ask you this question, but I do want to cover it just in case. So my original one, if you see it decaying like this, you can see that from the isotope, from where it gets really flat, right? The first full point I see is my y-intercept. So if I do the same thing to this one, so here's my isotope, the first full point, the first full corner I get, which is right there, is going to be my y-intercept. So this has been moved, my y-intercept has been moved from 1 to 3. And again, because it's opposite, it goes inside and opposite. So instead of plus 3, it's going to be minus 3. And there should be a little bit space to write that in. All right, let's do another graph one. So here's a graph of f of x. The solid black line, again, minus purple. Which function represents the dotted graph right here? So what has happened to it? I know this has flipped over, and we're going to follow, in things you can have the vertex follow the vertex. So I know the v has been flipped over the x, so it's a negative outside. All right, and then once it's flipped, so now it kind of looks like this somehow, we're going to move 1, 2 to the left. So we're going to say x plus 2 because x is opposite, and then 1 up. And so we're going to say plus 1. Please practice these without the calculator because you want to make sure that you're prepared. All right, so I'm going to look at this one. And again, if you have vertex, follow just the vertex because that would be a good point to follow. So again, I start here. I'm going to flip it because right now it's a U, but I need it to look like an N. So I'm going to flip it on the outside. And then what am I going to do with it? I'm going to move it right 2. And remember, it's opposite. So right would be minus 2 because it's opposite. And then I'm going to move it 1 down, and so that will be outside, so minus 1. Final calculator question. If j of x is this and k of x is this, and what's the only difference? Again, this is a growth problem, this is a decay problem, but we just talked about it in Desmos, so I can do this even without looking. Remember, they're all, whether it's growth or decay, right? Doesn't really matter aside from steepness. They're all going through the same y-intercept. So my decay problem and my growth problem are all going through the same y-intercept because, again, you can see A is invisible 1 and there's no C. The reciprocals of one another, the steepness is exactly the same, only that one is growth and one is decay. And then which transformation maps one of these to the other? So how do I go from this one to this one? I can just flip it over the y-axis. So if I imagine this is a book that I can close this side, it'll flip over to this side, and if I close it, it'll flip over to that side. So this is going to be a reflection in the y-axis. But however, because they've given me actual values, I could go ahead and put it in a calculator. So if you type that in the calculator, type that in the calculator, you're going to see this exact kind of picture. Let's practice.